Okay, let's take a look at problem 4. So in problem 4, you have this rotating code wheel, and you have got these two signals that are coming out of the code wheel, right? A and B. And A and B are 90 degrees apart. What we mean by that is, if so, let me draw A here. So let's say A is a signal like this. Okay, so if let's say A is a square wave like this, so 180 degrees phase shift would be B being exactly the opposite of A, right? When A is 0, B is 1. When A is 1, B is 0. So that would be a 180 degree phase shift. While 90-degree phase shift is basically something like this. So let's say when right at the middle of the cycle of 1, B B basically is a delayed version of A, right? So you have the signal like this. Then somewhere here in the middle it transitions, then it goes up in between, and it goes up, and so on and so forth. Okay, so that's how B looks. So that's A and B, and the basic idea here is that there are two LEDs here and two photodiodes here, and when the light when if this code wheel is rotating, what will happen is at some point there are these slots here, and the light passes through and touches the photodiode, so you can kind of you'll receive the light. At other points the light is not there, and they are so arranged that A and B have a phase shift, and depending on which direction the wheel is rotating, your phase shift, the B will be either a delayed version of A or a leading version of A, right? It will either lead uh, or delayed, and this basically can be will give you the direction. And what is being said is, okay, we are using this D flip flop to give us the circuit which is given here. We are using this circuit, and the output of that circuit is going to be the direction. So how how is that possible? So that's what we are asking. Okay, so think about it this way. So the flip flop here is a D flip flop, right? And the clock signal is edge triggered, and it is triggered at the positive edge, and B is going to the clock signal. So let's say this is the signal that goes into uh, this is the signal that happens when the wheel is rotating in a clockwise direction. So let's say when this is clockwise, okay, B is slightly delayed compared to A. Okay, and the flip flop works when it works at these edges, right? At the positive edges. So this edge, and this edge. Okay. Now, how does a D flip flop work? Remember, whenever there is a positive edge, if D is equal to 1, your Q is going to be equal to 1, and if D is equal to 0, Q is going to be equal to 0. Okay. So in that case, in this clockwise signal, in which direction, what is the output going to be? What is this direction? The output is called direction here. What is this going to be? Now notice that whenever the positive edge of the clock arrives, A is always 1. A is 1 here, A is 1 here, and A is 1 here, right? Which means that our output is always going to be equal to 1. So when our clock is rotating clockwise, our direction is going to be equal to 1. The output, which is direction, is going to be equal to 1. All right. Now let's just redraw our signal B, so that B is actually, instead of lagging, it is leading. Oh, I'm gonna try to. Okay, there you go. So I should be able to delete this. There you go. And now I can draw the A. So my A is like this. And my B is leading instead of lagging behind A, right? So you get, first you get this high, B becomes high, and then A becomes high. So that's how my signal is going to look, right? And we'll leave it at that. Now look at the positive edges of B. So this is the place where all the action happens, at the positive edges. And at the positive edges, what's the value of A? It's 0 here, it's 0 here, and it's 0 here, right? So when we have an anti-clockwise rotation, the values of A is always equal to 0, which means what is the value of direction going to be? Direction is going to be equal to 0, because this is a D flip-flop. So when we have an anti-clockwise rotation, direction is going to be 0, and when we have a clockwise rotation, direction is going to be 1. And that's how this D flip-flop helps us to find out the direction in which the code wheel is rotating.